In the wind energy sector, operational efficiency and asset reliability are fundamental pillars. Traditionally, maintenance has been managed reactively or scheduled, waiting for failure or adhering to fixed schedules. However, this approach presents significant limitations in terms of cost and availability. Predictive maintenance represents a paradigm shift toward a proactive strategy. Its primary objective is to anticipate failures before they occur, transforming asset management. This is achieved through the advanced use of data analytics, enabling precise and timely intervention. This approach is crucial for operations managers, O&M managers, SCADA engineers, data analysts, maintenance managers, and reliability technicians. For all of them, understanding and applying predictive maintenance is essential to optimizing the performance and profitability of wind farms. At the heart of this transformation is the intelligent maintenance agent. It acts as a proactive guardian of wind farms, constantly monitoring and analyzing data in real time. Its primary function is to identify potential problems before they escalate into critical failures. This agent is not a standalone entity, but rather a system composed of several specialized subagents. Each of these subagents fulfills a specific function, contributing to a comprehensive and highly efficient maintenance strategy. This modular architecture enables sophisticated and adaptive management. The diagnostics and prognostics subagent is the analytical brain of the system. Its mission is to process large amounts of data from the sensors installed on the wind turbines. It uses advanced machine learning algorithms and time series analysis to detect subtle anomalies. This subagent is capable of predicting the remaining useful life, or RUL, of critical components. It focuses on vital elements such as gearboxes, transformers, and hydraulic systems, which are prone to costly failures. Early detection of deviations is key to avoiding further damage. A practical example of its capabilities is vibration analysis. By detecting anomalous patterns in a gearbox vibrations, the subagent can predict an imminent failure with high accuracy. This allows intervention to be planned well in advance, avoiding unscheduled shutdowns. This predictive analysis goes beyond simple threshold detection. The system learns from historical data and the normal behavior of each component. Thus, it can identify deviations that, although small, are indicative of a developing problem. Accurate estimation of remaining service life is critical. It allows maintenance teams to schedule interventions precisely when needed, optimizing resources. This avoids both excessive maintenance and the risk of catastrophic failures. Once the diagnostics and prognosis subagent has identified a potential failure and estimated the remaining service life, the maintenance planning and logistics subagent takes action. Their role is to translate these predictions into concrete and optimized action plans. This subagent considers multiple variables to generate maintenance strategies. It integrates RUL data with personnel availability, spare parts inventory, and weather conditions. It also takes into account the wind farm's production schedules. The goal is to generate maintenance strategies that minimize the impact on production and operating costs. For example, it can group several maintenance tasks into a single period of low production or during low wind conditions. This maximizes the efficiency of interventions. Logistics planning is crucial to ensuring that parts and personnel are available at the right time. It avoids costly delays and the need for urgent spare parts orders. Anticipation is the key to efficient management. This subagent not only plans, but also optimizes. It seeks the best time window for each intervention, considering the balance between the risk of failure and the impact on energy generation. It is a complex combination that requires coordination of resources and schedules. The Maintenance Strategy Simulation subagent offers superior analytical capabilities for decision-making. It allows operators and managers to compare different maintenance approaches before implementing them. It simulates the impact of each strategy over time. This tool is invaluable for determining the optimal approach, whether condition-based maintenance or a more traditional strategy. It allows for assessing the impact on key metrics such as operating costs, asset availability, and equipment wear. For example, the effect of bringing forward or delaying a scheduled intervention can be simulated. The subagent will calculate the financial and operational implications of each scenario. This provides a solid justification for maintenance decisions. Simulation allows teams to explore what-if scenarios without risk. they can visualize the long-term consequences of different maintenance policies. This is critical for strategic planning and asset lifecycle optimization. By quantifying the impact of each strategy, the simulation subagent facilitates smart investment in maintenance. It helps identify interventions that offer the highest return on investment. It is a powerful tool for financial and operational management. The intelligent maintenance agent does not operate in isolation. It is an integral part of an ecosystem of interconnected agents within the wind farm. This collaboration is critical to maximizing availability and operational efficiency. The synergy between agents enhances individual capabilities. This agent receives vital information from the wind turbine control agent. It provides it with data on anomalies, load changes, and vibrations detected during direct turbine operation. This real-time feedback is crucial for diagnostics. Furthermore, the intelligent maintenance agent coordinates its actions with the orchestrator agent. This agent negotiates optimal windows for shutting down the turbines, balancing maintenance needs with overall energy production. Its goal is to minimize downtime and maximize generation. Access to historical data and real-time signals is provided by the data broker. This agent is the central repository of information, including environmental context, that is essential for accurate predictive analytics. Data quality and availability are critical. Finally, the intelligent maintenance agent greatly benefits from the continuous learning agent. This agent allows the intelligent maintenance agent's predictive models to be retrained as new faults are detected or more data is collected. This ensures that predictive accuracy constantly improves over time. This seamless integration between agents creates a highly intelligent and adaptable asset management system. It enables proactive, data-driven decision-making, optimizing every aspect of wind farm operations. Collaboration is the key to efficiency. The implementation of the intelligent maintenance agent has demonstrated tangible benefits in various real-world applications. These case studies illustrate how failure prediction translates into significant operational and financial improvements. The results are quantifiable and impactful. One example is the early detection of rotor brake failures. The system can identify small deviations in hydraulic pressure, predicting a failure weeks in advance. This allows intervention to be scheduled alongside other maintenance, avoiding unexpected downtime and reducing costs. Another example is the prevention of catastrophic failures in gearboxes. By analyzing vibration and temperature, the intelligent maintenance agent can alert users to a potential upcoming problem. This enables early replacement of critical components, preventing further damage and prolonging the asset's lifespan. Optimizing annual maintenance strategies is also a key benefit. The system can simulate different scenarios, comparing costs, times, and estimated production. This allows the most efficient strategy to be selected, improving overall fleet availability. The quantifiable results are impressive. A reduction of up to 65% in unplanned failures can be achieved, directly impacting operational continuity. Operational availability increases by up to 10%, maximizing energy generation. A 40% decrease in urgent spare parts orders has been observed, optimizing inventory management and reducing logistics costs. Extending the lifespan of critical components, such as gearboxes, by up to 18 months represents a considerable saving in capital investments. Together, these benefits translate into a significant reduction in operating and maintenance costs. Furthermore, they free up human resources from reactive and urgent tasks, allowing them to focus on strategic and continuous improvement initiatives, driving innovation and efficiency. Predictive maintenance, powered by the intelligent maintenance agent, is redefining asset management in the wind industry. We have explored how failure anticipation, optimized planning, and strategic simulation transform wind farm operations. The integration of intelligent agents creates a robust and efficient ecosystem. The benefits are clear: increased availability, lower costs, extended component lifespans, and more strategic human resources. This technology not only solves problems, but also creates long-term value. It is an investment in reliability and profitability. In the next video, we'll delve deeper into the environment and prediction agent. We'll learn how this agent uses advanced weather forecasting to anticipate conditions such as extreme winds, ice storms, or peak production periods. We'll understand how the wind farm can see the future weather and act proactively.